In this question, we're asked to simplify these integrations by removing these limits or by changing these limits. We're going to do that by using the fact that we have these unit step functions. And remember, a unit step has the effect of changing the limits of the integration. So for the first question, we have some function x of t, no idea what it is, but it's multiplied by a unit step, and the unit step starts at t equals 0. So when you multiply the two, clearly for all time less than 0, the result is 0. So if we were to rewrite this integration, it would be the integral of x of t times 0 from minus infinity to 0 plus the integral from 0 to infinity x of t times 1 dt. So clearly this is 0, so we're left with that. So multiplication by a unit step has had the effect of replacing this limit with this. So that's what we've done. We don't know the answer because we don't know what x of t is, but we've simplified the integration by removing u of t. So u of t is no longer mentioned in the integration because remember, u of t is either 0 or 1. So if it's 0, we don't write that part of the integration, and if it's 1, we don't write it either, we simply write x of t. So for the next question, it's exactly the same. We have a signal x of t, we don't know what that is, but it's multiplied by a shifted unit step. So the step starts at t equals 2 pi. So the unit step is 0 until time 2 pi. So everything before t equals 2 pi is multiplied by 0. So we needn't include it in the integration. So the effect is replacing this lower limit with 2 pi. And now we no longer need to mention the unit step because it's simply 1. So in here, there is a 1, just like in there was a 1. Okay, for the next question, it's exactly the same, but this time our unit step, so again I'm going to draw some arbitrary signal, and then we have a unit step that starts at t equals minus a. So you say t plus a equals 0, t equals minus a. So the unit step starts at t equals minus a. So everything to the left of that, everything before t equals minus a, isn't included. So your integral has this lower limit replaced by minus a. Now the next example is slightly different because we have u of minus t. So u of minus t is a reversed unit step. It's a unit step that's 1 for negative time and 0 for positive time. So when you multiply those two functions, you'll see that everything for t greater than 0 is 0. So this time, rather than replacing the lower limit, we're replacing the upper limit. So the upper integration limit becomes 0. So we're integrating from minus infinity to 0. Next question is similar, but this time we have a reversed and shifted unit step. So if you solve that, we have the unit step becoming non-zero at t equals 4. And because it's flipped, it's reversed, because of the minus sign there, it means that the unit step actually looks like this. So when is the product 0? For all time greater than 4. So the only time when the integration is non-zero is between minus infinity and 4. So we replace this upper limit with 4. The next example is similar, but now we have 2 unit steps. So our first unit step is at 0, so that's nice and easy. The next unit step, so that's my first unit step. My next unit step is the same as the one we just drew. It's at 4 minus t. So let me draw that in orange. So that extends until t equals 4. And if you multiply those two, the only time when the product is non-zero is between 0 and 4. Because you see, after t equals 4, you're multiplying by 0, and before t equals 4, you're multiplying by 0. So if you have your signal x of t, the only time when it's multiplied by something other than 0 is between 0 and 4. So rather than replacing one limit, we're replacing both limits. So the answer has these limits replaced with 0 and 4. And the final example is exactly the same, really, because you have these two limits here, or these two unit steps. And instead of 4, we have a variable b, or a constant b, and instead of x of t, we have this value a. So if I wanted to plot that, it would look something like this. So my signal, I'll draw in pink, might look like that. That's my signal with amplitude a. So that's my x of t. Now we have 2 unit steps. A unit step from 0 onwards. So that's that. And then we have a reversed unit step because of the minus sign, and it happens when b minus t equals 0. That means when t equals b. So if I do that in orange, that's a reversed unit step at t equals b. So if I multiply these 3, when is it non-zero? Well, it's 0 for b time greater than b, and it's 0 for time less than 0, because here we're multiplying by 0, and here we're multiplying by 0. So it's only non-zero for this brief period between 0 and b. So that's why we can write the answer like this: integral from 0 to b of a dt. But whereas in previous questions here, we could have just stopped by writing the integration. Now we have to actually integrate. So what's the integral of a dt from 0 to b? Well, it's just AT, isn't it? From 0 to B, which is AB minus A0, which is AB. So that's my answer. But is it the final answer? Well, not zero, not really. Because that's my answer only if B is greater than 0. You see B here? B is greater than 0. That's how I sketched it. But what if B was negative? If B was negative, it would be here. That would be B less than 0. And then when you multiply, you'd have no overlap. It would be 0 and 0 and 0. So if you were to then multiply, your answer would be 0. So which is the answer? Is it A times B or is it 0? Well, what we're trying to say is the answer is A times B only when B is greater than 0. Mathematically, there is a nice deterministic way to say that. If we were to say A times B multiplied by a unit step of B, that means it's A times B if B is positive, and it's 0 if B is less than or equal to 0.